Today we're going to talk about lesson 4-8, compound inequalities and or. The big idea is placing and between two sentences means that you want the intersection of their solutions. Intersections are notated by using an upside down U. So we call this A intersection B. This is the intersection symbol. And what you can think of intersections as is two roads or two streets intersecting each other, and what they have in common is this little section of pavement. So that's what happens when you have an intersection. Okay, there's only a certain part of it that is together. Placing or between them means that you want to union or want the union of their solutions. So how we note unions is A, U for union, B. And this means union. And what you can think of it as a wedding ring. And this is going to be an ugly cut diamond. Guys, don't give your wife one of those. Okay? But yeah, you can think of a union as marriage. Now, typically what happens in marriage, whatever he has, you get. Whatever she has, he gets. We all know that's not the case, guys, because a lot of your stuff normally gets thrown out. But the idea of a union is typically like a marriage where you merge everything together. Okay? The language of compound sentences. A car's water temperature gauge is an indicator of the engine cooling system. The gauge is marked to highlight normal temperatures as shown. Temperatures below 40 degrees Celsius occur when the car is warming up. Temperatures above 120 degrees Celsius indicate that the engine is in jeopardy of breaking down. These temperatures can be graphed. Using T to represent temperature, each graph can be described with a pair of inequalities. Normal temperatures. Okay, a car's normal temperature says it can be greater than or equal to 40 and less than or equal to T. Or T is less than or equal to 120. So a car's temperature when normal is in between 40 and 120. Abnormal temperatures. You could have two inequalities that say what the abnormal temperatures are. T is less than 40 or T is greater than 120. Okay? The graph is two rays without their endpoints. Okay? Open circle going that way, open circle going to the right. It says a compound sentence is a single sentence consisting of two or more sentences linked by the words and or. The above graphs are described by compound inequalities. The compound inequality at the left can be written as a double inequality. 40 degrees is less than or equal to T is less than or equal to 120. Okay? Intersection and union of sets. We kind of just talked about that. Okay? I want you to mark these. These should be in your notes. This should be written down. A intersect B, upside down U, is a set of elements that are in both A and B. They have something in common. Union of sets. Union of sets is what I said. It's like a marriage. Everything merges together. We're taking everything that are in those sets. Okay? So example 1 says, let A equal the set of numbers for which X is greater than 8. So let's just graph that on a number line. X is greater than 8. So we have 8, we have an open circle, and we're graphing everything that is going that way because it's greater than, to the right. B, so this is A, this is going to be B, so I make a number line for B. It says a set of all numbers for which X is less than or equal to a negative 3. So we're at a negative 3, which is less than 8, right? And we have a closed circle at a negative 3. And we are going to take everything that is less than that. So there's this gap from a negative 3 to a negative 8, correct? And it says graph the set A union B. So we want everything in A, we want everything in B, so we got to include both of them. So when I graph this inequality, okay, it says we want everything in A, we want everything in B, and how we would describe this set is we would have to use the OR statement. Why the OR statement is because these two things are separated. So we can, how you could describe this set is we want everything that is less than a -3, including a -3, or it falls into the greater than, x has to be greater than 8. Okay? So we would have to use OR in this inequality. Okay? Because of the separation. Example 2 says, a family purchased some neon tetras to put in their new fish tank. They looked on the internet to determine at what temperature to set the tank water. One site wrote to keep the water temperature from 72 to 78. So first site, 72 degrees to 78 degrees. The second site said it needed to go from 68 degrees to 74 degrees. And the third site wrote 73 degrees to 81 degrees. To be safe, at what temperature should the family keep the tank? Okay? Well, if you look at this, this is from 72 to 78. Okay? So we'll just use that as our means right now. So they're saying from 72 to 78. Okay? These guys are saying from 68 to 74. And notice we can't include them, so you want to use the closed circles. And these guys say from 73 to 81. So all very different. So when you look at these, what we're probably going to want to do is we are going to want to see where all these intersect at. So we want all the temperatures where they are all common at. Okay? Well, from here, this is going to be very tough because the less than, this has 72, this has 68, this has 73. So if we're thinking about an intersection, 68 doesn't go with this one or this one. 69 doesn't go with that one or that one. What you want to do is you want to look at the lowest or the highest lowest value. So this has 72, this has 68, this has 73. Okay? So 73, when we union these, is our lowest value. And now you want to look for the lowest high value. What's my lowest high value? Well, my lowest high value is 74. So what we are going to want to set our tank at is 73 to 74, and what that is going to do for us, it's going to keep us at ease because all these temperatures that we got from each site, this is their intersection. It's a temperature where they all say that they are fine at, these tetras, okay, where they are going to live at, okay. So, moving on. Describing intervals. Most people would say that the average body temperature is 98.6 degrees Fahrenheit. This figure was arrived at in the 19th century. Recent medical research has established that the mean temperature for healthy people is at 98.2 degrees Fahrenheit. However, there is some variability among healthy people. According to a new standard, the normal range varies above or below 98.2 by 1.5 degrees. So what this means is 98.2 plus 1.5 and 98.2 minus 1.5. That interval in there, people are safe, okay? Which gives us this inequality of 96.7 is less than or equal to T is less than or equal to 99.7. So what they are saying is some people have high temperatures, some people have low temperatures, okay? So a doctor is not going to get nervous when your temperature is in between 96.7 and 99.7. Now, they'll make a difference of maybe your temperature is always low. So if your temperature is always low and it hovers around this 96.7 and you come in with a 99.6 temperature, yeah, they're going to probably think there's something wrong, maybe some infection, something like that. But that's why you go see a doctor on a continuous basis, at least once a year. That way they have that history of knowing where your temperature is normally at. Some people's run high, okay? So vice versa. You have to keep that in mind when you're a doctor and all those other things. You can combine 98.2 plus 1.5 and 98.2 minus 1.5 into one expression using the plus minus notation. All this means is you're going to take 98.2 plus 1.5, get 99.7, take 98.2 minus 1.5 to give you 98.2 minus 1.5, which is going to give you 96.7. Okay? Let's look at example 3. Let's solve some of these. And what you have to do when you see a problem like this is you have to break it up into two problems. Example 3 says, solving graph, a negative 8 is less than or equal to 5m plus 4 is less than 19. So I want you to watch. You take, for your first problem, I like to call them cases. Case 1, case 2. Case 1 is you take everything that is in with the first inequality. Everything in the middle with the first inequality. So this becomes negative 8 is less than or equal to 5m plus 4. Very important to pay attention to. That's my first problem. Then you have to take everything in the middle once again and take it to your right inequality, which becomes then 5m plus 4, or is less than 19. So very important you pay attention how to set this up. You need to pause it, take a look at it. This is the first problem. This is the second problem. Case 1, case 2. Then you solve for m, which we all have done before. So I get to subtract 4. Leaves me with 5m is greater than or equal to a negative 8 minus 4 is a negative 12. Okay? Inverse operations. The inverse of multiplying by 5 is dividing by 5. M is greater than or equal to 12 divided by 5. You all should be telling me is 2 and 2/5, or what you could say is 2.4. And we know negative divided by a positive is negative. Okay, so there's one answer. Same process, solve for m, subtract 4, subtract 4. Gives me 5m is less than 15. Divide by 5. M is less than 3. Okay, so here's my second answer. If I wanted to put both of these on my inequality, I have a negative 2.4 as my point of interest. I have 3 as my point of interest. Closed circle on the 2.4. Open circle on the 3. Now, you got to read from your variables. So it says m is greater than or equal to a negative 2.4. So we know we're going to the right. This says m is less than 3, so we know we are going to the left. Which means, if you notice, this has to be greater than, this has to be less than, therefore, the inequality is just these two things merged together. Okay? Moving on. Same type of process here. Example 4. When they use the OR, what's great about that is you already see the two problems. Solve 13y plus 86 is greater than y plus 2. Or 2y plus 9 is less than 5y. So here's problem 1. Here's problem 2. Case 1. Case 2. So 13y plus 86 is greater than y plus 2. 2y plus 9 is less than 5y. I'm going to do the easy problem over here first, so I'm going to subtract 2y because I got to get my y's together. Leaves me with 9 is less than 3y. Therefore, divide by 3. Y is greater than 3. Okay. Up here, I got to get my y's together, so I got to subtract y. Gives me 12y plus 86 is greater than 2. I got to get my numbers together, so I got to subtract 86. y is greater than, notice I didn't multiply or divide by a negative number, so I leave it the same. 2 minus 86 is a negative 84. And divide by 12. And I didn't divide by a negative number, so it stays y is greater than. And we all should know that that is a negative 7. So on my inequality, I have a negative 7, open circle. It says it wants all numbers that are greater than, so I know that's going to the right. This says y is everything that is greater than 3, so at 3 I have everything that is open circle, everything that is greater than. So theoretically, since both these are headed to the right, I only need one inequality to solve this equation, and that is y is greater than a negative 7. And why do I only need that? Well, y is greater than negative 7, okay, also includes your greater than 3. So therefore, you only need that one solution, okay? That's all I have for you today. Please enjoy. We'll see you tomorrow.